We're going to be working with this scenario here. It's a report that's come out from the Journal of the American Medical Association. But essentially what's going on is in this scenario, you presume you worked for the Center of Disease Control, and you've been assigned to research the case or the cause behind the incidence rate of stroke occurring more often in winter months, especially up north. And obviously the notion here would be is there some, and you can see here what's going to happen is we're going to look at different forms of exercise and snow shoveling. And basically the premise is that perhaps older men in this situation, shouldn't be out shoveling snow, especially given if they're sedentary. Okay, so let's take this from the top and go through the scenario real quickly here. A study from as mentioned, the study from the Journal of American Medical Association investigated the cardiac demands of heavy snow shoveling. 10 healthy men underwent exercise testing with a treadmill and a cycle ergometer modified for hand cranking. So it's just a hand crank exercise device. The men were then cleared 2 tracks of heavy, wet snow by using a lightweight plastic snow shovel and an electric snow thrower. And then they were also, at the same time, the same subjects were compared to the beats per minute of the heart for the treadmill and the arm crank. And here are the different outputs from that sampling. And there were 10 subjects, and each of them went through treadmill, the ergometer, the hand crank, snow shovel, and snow thrower. And you can see here each of the heart rates or beats per minute for the activity. Now, to investigate this, we're going to start out with the way we normally start it out is what is that what's that problem or scenario, or what's a problem statement, what's a good problem statement here or opportunity. But this is really potentially more of a problem. You want to investigate the beats per minute by activity, correct? And then, especially for sedentary individuals, this might be an issue. And so the problem is you've just noticed that there's been an increase in the incidence rate of heart attacks, especially up north in the northern states during the winter months. And so you're going to investigate that and try to make a linkage between beats per minute by activity, and eventually, hopefully, make a linkage between those activities and the incidence rate of heart attacks or strokes. Now, the purpose. What policy outcome or research would this impact? Well, the fewer strokes is always a good cause, and you wanted to more or less take a look at whether there's this incidence rate at the CDC that they've been recognizing what might be causing that. And so the first place you're going to start is with each one of these activities, and with the intent of lowering the incidence rate of heart attacks, which in turn lower medical costs, and on and on and on. So an appropriate research question would be, does BPM, or the heart rate, increase dependent upon the activity? And you're going to need more information here to fully address the problem and the that we've got before us, which is thoroughly investigating that incidence rate of heart attacks and strenuous exercise. But let's see where this goes, and then we'll pull that down the recommendation if we do find that there is something to investigate further there. So what is the most appropriate null hypothesis? Well, HO, same nomenclature before, is the mu sub 1 is equal to mu sub 2 is equal to mu sub 3 is equal to mu sub 4, where each one of these types of exercise, which was the treadmill, or activities, the treadmill, the arm crank, the snow shovel, and then the snow thrower is what we've included in the analysis. Okay, so that's what each one of those are. And HA is all of the mean BPMs, or heart rate, are not the same. And if we find that they're not the same, then we've got a little more work to do. But let's keep pushing down the analysis here. What type of a hypothesis test are you going to conduct? Well, since you got 4 different means that you want to analyze as to whether there's a difference, and then potentially where that difference might lie, rather than doing 8, 9, 10 t-tests to compare all those together, you just bump it up to an ANOVA analysis, or an ANOVA testing. We're going to do that at 95%. Okay. As far as the confidence level goes, the variables are going to be heart rate in beats per minute, and then the type of activity. Invalidity or bias, well, the term wet snow can vary by location. The weight of the snow would be impacted in that regard, and so there might be some other weather, how cold it is, in where the tests were conducted, and on and on. So there might be some invalidity exposure in that regard. Now we conduct this ANOVA analysis, and what do we discover? Well, the first question is, what is the p-value for the test statistic? The test statistic, this is an F analysis, or an F test, but we don't really worry too much about that. What we really look for is this value right here, the 0.000, or it could be any value, right, depending upon the testing. But what that's telling you is that because that's less than 0.05, and we conducted this analysis at 95% confidence level, so if it's less than 0.05, the p-value, or this what they're calling sig value, which is the same as the p-value, associated with F, okay, that's F is the test statistic. We really don't worry about the test statistic, but we could use that if we were doing the testing model like we did with the the original t-testing. But let's not concern ourselves with that, and let's just focus very quickly right on this p-value. And you can tell up here, the other important part of this is up in here, right? And you can see that the mean was 178 for treadmill, arm crank was 173, snow shovel was 171, and the snow thrower was 123.6. So you're seeing a little bit of a differentiation going on, but let's see if where that difference might lie, and very clearly at this point, with that p less than 0.05, 0.000, you would reject the null. So we found out that the p-value for the test statistic F is equal to 0.000, and it probably continues on here for a while, but it's basically 0. So would you reject the null hypothesis? Absolutely. That p-value is less than 0.05 for the overall model, and therefore you would reject the null, which stated they were all the same, and you would accept the alternate, meaning that all of the means are not the same. So now the question becomes, as we discussed in class, which one of those is like the other? And we're going to run an LSD, and that was, I included that, as you might have seen before when I had this up. We had this post hoc test, multiple comparisons of the LSD. And where you pay attention here is in the for each one of these comparisons, is the difference significant? Well, you can see here, and you know, SPSS kind of helps you a little bit. The difference is significant. It puts it right here where that difference is significant at. So if you compare the treadmill to the arm crank, 0.524, there's no difference in the means there. There's no difference in the means there, but between the treadmill and the snow thrower, there is a difference, 0.000. So kind of see where this one might be going. Okay, let's take the arm crank and the treadmill, no difference. Snow shovel, no difference. And the snow thrower, again, that's showing up as the one that's not like the others. And we can go on and on, but you can come right down here and say, okay, the snow thrower, is that different from the treadmill? Absolutely, 0.000. Is the arm crank different? 0.000. And the snow shovel. So these are all the same, which kind of helps the analysis, because if the beats per minute for snow shoveling are the same as a treadmill and arm crank ergometer, then if you're a sedentary individual and all of a sudden you go out and start shoveling snow, you're not doing any treadmill or any type of exercise, clearly your beats per minute are going to be elevated from what would be considered a normal or an at-rest BPM. So the snow thrower could be a solution. Quite frankly, that's kind of where this is pointing, but let's keep pushing ahead before we go toward a solution. So at P.05 LSD, we know that the snow thrower definitely has a lower BPM than the other activities. So what is the answer to the research question? Well, yeah, it really does change. The heart rate or the BPM does change depending upon what type of exercise. And in this case, when you're shoveling snow, a wet snow, you're exercising or stressing your heart at the same level on a BPM basis as you would if you were on a treadmill or an arm crank device that you're exercising on. So if you're sedentary, could very well be an issue here if you can kind of come down here and make an additional linkage. So the answer here would be, yeah, there's something going on that we need to investigate further. But then you would the further research. So further research is what the recommendation would be here. Is to find a linkage between elevated heart rate or BPM and stroke, with perhaps an emphasis on sedentary males. And in your next study, you might also include sedentary and active males in your research to do that compare and contrast to see if the incidence rate is different there for further research. But that would be a whole nother sort of methodology and research question that we would have to develop. So that's the way you would analyze this case and an ANOVA, with the understanding that you didn't have to run all these t-tests. You just run one single ANOVA. You figure out where the difference is. You let the computer do the work for you, and you've got an answer to your original question was, does BPM increase by activity? And the answer was definitely, you bet, because you rejected the null at 95%.